Hi guys, this is Mrs. Cribb. I'm going to go through a few of the questions from the homework packet for this chapter. So this would be tutorial 4. This is the worksheet that actually says concentration worksheet 1. And I'm going to go ahead and do number 2, even though you are supposed to omit that one, mostly as a practice. So you'll be able to see how to do it, how to do some of the concepts from the other pieces. So this says, how many grams of beryllium chloride? All right, beryllium chloride. The first thing we're going to need to do is figure out what beryllium chloride is. So beryllium is Be, chlorine is Cl. Chlorine has a -1 charge, and beryllium has a +2 charge. So you have to do the crisscross here. So the beryllium chloride is BeCl2. So that's the first thing. So how many grams of beryllium chloride would you need to add to 125 milliliters of water to make a 0.050 molal solution? Several things you need to remember is that 1 liter of water is 1 kilogram in mass, because the density of water is about 1 gram per milliliter. So we have to turn this into kilograms, because what is molality? Molality, little m, is moles of solute per kilogram of solvent. Okay, and water is a solvent here because we're telling you we're putting the grams of beryllium chloride and we're adding it to the solvent. So first what we need to do is, now I know I have beryllium chloride, and that's the moles of solute. We're going to try to be figuring out first the moles of solute and then turn it into grams. And I also know what the solvent is, 125 mils, so I got to turn that into kilograms. So 125 milliliters, and the density of water, like I said, is approximately 1 gram per mil. So 1 gram per mil, and milliliters are going to cancel, so it's 125 grams of water. But I need to have it in kilograms, so 125 grams, you divide by 1,000 to get to kilograms. So 1, 2, 3, so that's 0.125 kilograms. So now I can put that over here. Now, the molal solution, they told us here, is that we're trying to make a molal solution of 0.050. So remember what that means. That means 0.050 moles of solute is going to be in every 1 kilogram of solvent. And so we set up these equivalent fractions and then solve for the unknown. So how many moles then will we need in 0.125 kilograms? Okay, we cross multiply and solve for that. So x moles times 1 kilogram equals 0.050 moles times 0.125 kilograms. All right, divide both sides by 1 kilogram, and x mole is going to equal, so I'll pull up my calculator, move it over a little bit, turn it on, we have 0.05 times 0.125. So there's the number of moles that I would have, 0.00625. Now, there are 2 significant figures here, so I'm going to go ahead and change that to 0.006, .0063 moles of beryllium chloride. Okay, that's the number of moles of beryllium chloride, but I need to know the grams, so I've got to use the molecular mass, the molar mass rather, of beryllium chloride, so I've got to calculate that out as well. So I'm going to do that off to the side here. Beryllium and chlorine. If you look on the periodic chart, you see that beryllium is 9.01 grams, and we have 2 chlorine atoms at 35.45. We add this together and we get 79.91 grams per mole. That is the molar mass. So I can use the molar mass to turn the moles into mass, just like you've done all through chapter 9. So 79.91 grams per mole and this will tell me how many grams of beryllium chloride I need to add to create this particular solution. So 0.0063 times 79.91, and I get 0.5, I think that was 0.50, yeah, 0.50, because I need two significant digits. So 0.50 grams of beryllium chloride. So what does that mean? Okay, I'm going to change colors up here for a second. It means in order to create this solution, the concentration of it, and I only want to make 125 milliliters of that solution, I need to add 0.5 grams of beryllium chloride to 125 milliliters of water. Now notice that we're adding the solute to the solvent and bringing it up to that particular volume so that we end up with 125 milliliters. If we put 125 milliliters of water in there first and then add half a gram, the volume would be slightly off because beryllium chloride is going to take up some space and it's going to add volume to that solution. Okay, now we're going to go over one of the questions from the concentration review worksheet. This is going to be number 2A, which is not one of the ones that I've omitted. So you do have to know this one, but I want to go over it a little bit at a time. So what is the molarity of methanol solution? Okay, we have a methanol solution here. We said we make a solution by adding 35 milliliters of methanol until the final volume is 275 milliliters. And so this right here, the 275 milliliters, this is equal to the volume of the solution itself. Okay? All right, now we're going to need to know the molarity, and molarity is moles per liter. So moles of solute per liter of solution. Okay, so what does that mean? That means this 275 milliliters right here has to be turned into liters. So 275 milliliters, this time I'll work it out. There are 1,000 milliliters in a liter, so 0.275 liters. Okay, so that's the beginning. Now that I know that, I'm going to need to figure out, see, what is the molarity of the methanol in this solution? The density of methanol is this. Okay, so how's that going to help us? Well, whenever they give you something, obviously that means it needs to be used. Okay, with the methanol here, they told me what I did was I took 35 milliliters of it and diluted it up to 275. So this is the amount of methanol I had initially, 35 milliliters. Well, that doesn't help me with moles of solute, so I've got to turn that into some kind of grams and then turn the grams into moles. So take 35 milliliters of methanol. All right, and what do I know? Well, if I use the density, because that's something that's given to you, you should always try to use whatever they give you. It tells me 0.792 grams of methanol are in every 1 milliliter. Well, now I can cancel that out, multiply that together, and that ends up being 27.72 grams, which is approximately 28 grams. And I do the 28 grams because of the two significant figures right here. Okay, so I have 28 grams of methanol. All right, well, we're getting closer now because I know the liters of the solution, but I need to know the moles of the solute. And since methanol is the thing I have the least of, it's the moles, it's the solute. So I've got to turn the grams of methanol into moles. So what do I need to know? Again, I need to know the molar mass of methanol. So let's calculate the molar mass of methanol. There's one carbon atom. There are 4 hydrogens. See, hold on. There's 3 right here and 1 more. So 4 hydrogens. So 4 times 1.01. And then there's oxygen. 1 oxygen. 16. All right, we'll pull up our calculator and add all that together. 12.01 plus 4 times 1.01 plus 16, 32.05. So that's the molar mass of methanol, 32.05 grams per mole. Right? I know I have 28 grams to start with, so let's turn that into moles. So 1 mole weighs 32 grams, and you can see here that that means I'm going to have just a little bit less than a mole because 28 is slightly smaller than 32. And that ends up being 0.87 moles when you put it in your calculator. All right, now I have what I need to put into this ratio up here, moles per liter. I'm going to change colors just for the fun of it. We have 0.87 moles, and we have right over here 0.275 liters. We divide those out and we get 3.16, which is approximately 3.2 molar. Remember 2 sig figs because that's 2 sig figs right there. Okay, so again, the only thing that made this a little trickier is remembering to use this density right here to convert the milliliters into some kind of grams. And then I use those grams and convert it to moles. And then I can put the moles inside the formula of moles per liter to get the molarity. Okay, I'm going to do one more question on this particular tutorial, and this is from the Making Solutions practice worksheet. We're going to do question number 1. Okay? All right, explain how you'll make 450 milliliters of a solution that has this concentration at 0.250 molar sodium hydroxide. Okay, so again, you're going to set up equivalent fractions. So we take what we want, 0.250 moles per liter of sodium hydroxide. It's going to equal how many moles of sodium hydroxide in this much, which is, we have to turn it again into liters. So 1, 2, 3 divided by 1,000, so it's 0.450 liters. All right, cross multiply and solve for the number of moles. X moles times 1 liter, 0.250 moles times 0.450 liters. Divide by liters on both sides and they cancel. So the number of moles that I end up needing is 0.113 moles, because see, we divided by 1 liter on both sides. Liters cancel. All right, so that's the number of moles of sodium hydroxide that I need in order to dilute it up to 450 milliliters. And so that's good, but I can't go to the scale and weigh out 0.113 moles of sodium hydroxide. I can weigh out some grams. So I'm going to have to turn this moles into grams. All right, so again, let's calculate the molar mass of sodium hydroxide. Sodium is 22.99, oxygen is 16, hydrogen is 1.01. We add those together and we get 40 grams in every mole. All right, so now I can go over here and turn this into grams. There are 40 grams in a mole. And I multiply those guys together and I get 4.52 grams. Okay, now I can explain. And that's the key here, is explain it. How do I make the solution? Okay, you dissolve, so you'd have to go to the scale first and weigh this out. I'm going to dissolve 4.52 grams of sodium hydroxide in water until it reaches 450 milliliters. That's how you do it. See, I can go and take sodium hydroxide and weigh it on the scale and put it into a container and pour water into it until it reaches the volume of 450 mils, and I will have made a solution that is 0.250 molar of sodium hydroxide. Okay, that's the end of this tutorial. The next tutorial will be over the questions on the dilutions worksheet, which is completely bonus.